Hey, AP Physics students. Here are some hints about the textbook assignment T7.1. And so T7.1 starts with a container filled to the brim with water and with some mercury. And so I've got a diagram for you that I think will help. Making diagrams always seems to make the problem work a little bit better. There is a height of 1 meter for the material that's in this 1 meter. It has mercury at the bottom, which I've indicated with red, then water. The 1 meter has the height of the mercury plus the height of the water. So the 1 meter is the total of the two. And here's what they're asking. They're saying at this point on number 29, what should be the depth of the mercury? So we're solving for H sub n. What should be the depth of the mercury so that we get twice the atmospheric pressure? From the lecture notes, you'll recall, and this is one of our primary formulas, is the pressure you get is equal to the pressure P0, which is the atmospheric pressure that we're starting with, plus the rho GH, rho being density, G of course 9.8, meter per second squared on Earth's surface, and H being the height. So just to get you started, the P that we start with will just be the atmospheric pressure, which we know what it is. You can look it up, and I've mentioned how many pascals that is, and that's what we want to use, pascals. So the pressure you get is equal to, that we begin with, is equal to, so whatever pressure you have is equal to the atmospheric pressure plus the density of the water, which again you can look up, times G times the height of the water, plus the density of the mercury times G times the height of the mercury. And in this case, I'll give you a quick hint. We are going to take this and double it. Okay, so twice, so we wonder, when will the pressure be twice the atmospheric pressure? Okay, so at that point, you will have this, and this, and this rewritten, but with one tiny little change from the general formula. So we wonder when it will be twice the atmospheric pressure right here. And one thing that will be helpful is we have two unknowns here. However, why not write this as one unknown? If we know that the water and the mercury height add up to 1 meter, can't we simply write something like, instead of writing the height of the water, why don't we call that 1.0 minus the height of the mercury? And then we should be able to solve that nicely if you continue. Now, let's look at number 37 on the next page. And so when you look at number 37, this is a basic hydraulic problem. This will be somewhat easier than the previous problem. So this is a hydraulic problem. And when we use hydraulics, recognize that the force that you apply, say F2, is equal to the F1 times A2 over A1. To get the diagram for you, if you look here, there are forces on both of these. So you can find the force by using our spring force formula, and here this is the force of gravity. So for instance, you might say the force F2 is K times X. Remember, Kx is the force you have on a spring. And then the force F1 might be very appropriately described as the force of gravity m times g. Hopefully this will assist you on these problems. Have a great day.